this area needs to be revolved about the line x equal to 2. Now tell me, if you revolve this area about the line x equal to 2, will you be generating a disk or a washer? If you notice here, that area is actually in contact with the axis this time. Therefore, we will be generating disk this time. When you take an element area, that element area will be in contact with the axis of revolution. There will be no hole when you revolve it. So we are using disk in this case. Okay. So to revolve it about the line x equal to 2, take a strip area dA of width dy. You can see here the width is dy. Why not dx? The width can be dx only if the area is a right angles to the x-axis. This is now a right angles to the y-axis. So the width is dy. Now, that means you need to represent y equal to 2x squared as a function of y, because this time we are measuring these distances. We need to represent the function as x equal to something. I hope you are now clear with these. We need to represent y equal to 2x squared as a function of y by solving for x. We actually did that earlier when we obtained the volume of revolution about the y-axis. What is that we obtained? X equal to square root of y over 2. Is that right? We did that already. So this distance, this is the distance called x equal to square root of y over 2. The distance of the graph of this function from the y-axis. And what is this distance called? That distance is called x equal to 2. Alright, so f of y, this graph is the graph of f of y equal to square root y over 2. There you go. And this is your g of y, that is 2. G of y equal to 2. Alright, now what are the limits of integration? This area dA can be anywhere from y equal to 0 to y equal to what? We actually solved this point of intersection. Well, we solved and we got y equal to 8. So this dA can be anywhere from y equal to 0 to y equal to 8. Alright, there you go. So the position dA can be anywhere from y equal to 0 to y equal to 8. Now the distance from the y-axis to any point on this curve we just talked about, the distance of the y-axis to any point on this curve is x equal to square root of y over 2. That distance, x equal to square root y over 2. And the distance from the y-axis to the line x equal to 2 is simply x equal to 2. So that is x equal to 2. And therefore, what is the distance from the curve to the line x equal to 2? What is this distance? What is the length of the element area? The length of the element area is the distance from the curve to the line x equal to 2. And that distance is this whole distance, which is 2, minus this distance, which is x equal to square root y over 2. I hope that is clear. We need to get the length of dA. Length of dA is this whole distance, which is x equal to 2. And minus that distance, which is x equal to square root y over 2. So the distance from the curve, from this curve to the line x equal to 2 is 2 minus square root y over 2. And that is the length of the element area dA. So the length of dA is 2 minus square root y over 2. Alright? There we go. When dA is revolved about the line x equal to 2, we generate the disk. And what is the radius of that disk? The radius of that disk is this distance which we just obtained. This is therefore the radius of the disk generated. So uppercase R, the radius of the disk is 2 minus square root y over 2. Alright, that's the disk that is generated. This is the line x equal to 2. The radius of that disk is 2 minus square root y over 2. Alright, what is the volume dV of the disk generated? What is the volume dV of that disk generated? dV is pi times r squared dy. That will be pi times our r is 2 minus square root y over 2 all squared dy. And you need to simplify this. Can you simplify that? That will be square of 2, that is 4, minus 2 times 2, that is 4, times square root y over 2, that's the middle term, plus the square of this quantity, that is y over 2. So that will be pi times 4 minus 2 times square root 2. You see, when you multiply this, it will be 2 times 2 multiplied by y over square root of 2. When you simplify that, this 2 and the square root of 2 can be simplified and you get 2 root 2. In other words, it is 2 times 2 divided by square root 2, which is 2 root 2 times square root y. Alright, and the last term is plus the square of this, which is y over 2. Well, by this time, these kind of algebraic process must be simple for you. A minus b all squared is a squared minus 2ab. 2 times square root y over square root 2 is 2 square root 2 square root y, plus the square of square root y over 2 is y over 2. And now we can obtain the total volume by integrating this dV from y equal to 0 to y equal to 8. So the total volume is pi times integral 0 to 8 of this quantity. And to integrate this, remember, square root y is the same as y to the power of 1/2. So we need to write it that way. Now, when you integrate, let's integrate each term. Integral 4 dy is 4y minus 2 square root 2 is a constant, and square root of y is y to the power of 1/2. Integral of y to the power of 1/2 dy is y to the power of 1/2 plus 1 over 1/2 plus 1. 1/2 plus 1 is 3 over 2. So it will be 2 root 2 y to the power of 3 over 2 over 3 over 2 plus integral y over 2 dy will be y squared over 2 divided by 2, which is y squared over 4. And the limit from 0 to 8. Again, because each term contains y, when you use the lower limit, they all become 0. So we need only the upper limit. Okay, let's use the upper limit. That will be 4 times 8 minus, look at this, 3 over 2. 3 divided by 2, that 2 will go up and multiply with this 2 to give you 4. So that will be 4 square root 2. Replace y by 8, you get 8 to the power of 3 over 2 over 3. Now remember here, 3 divided by 2, that 2 goes up to the numerator, gets multiplied with this 2. That will give me 4 square root 2 over 3. That's what this is. Plus 8 squared over 4. Now tell me, what is 8 to the power of 3 over 2? Well, that will be actually square root of 8 raised to the power of 3. Square root of 8 raised to the power of 3. Or 8 raised to the power of 3 and take the square root of that. That is 8 to the power of 3 over 2. Or you can put it on the calculator. And put this all on your calculator. That will give you 4 times 8, 32, minus 128 over 3, plus 16. And simplify that again. That is 16 pi over 3 is the volume generated when this area is revolved about the line x equal to 2. So actually these 4 parts of the problem give you all the skills you need to solve any problems of this type. And now try this on your own. Find the volume of the solid generated by revolving the region bounded by xy equal to 6. Now you got to read it as, you can take it as x equal to 6 over y, or y equal to 6 over x, and so on. So xy equal to 6, y equal to 2, and x equal to 6 about the line x equal to 6. That is a good exercise. I have actually worked it out for you in the PowerPoint. So check it out if you have some difficulty. But try and draw the graphs of these two functions and identify the area enclosed and try and revolve it where? About the line x equal to 6, and try and set up to obtain the volume generated. All right?